This is your first installment of the flip notes. We talked a little bit about this in class, but you're going to take notes like you would in class using this video. So if you need to stop it or pause it or rewind it, you can do that as much as you want. This is for Chapter 2, which is the chemistry of life. The first thing is we need to talk about matter. So matter is anything that occupies space and has mass. When we say mass, it's not the same as weight. So not the same as weight here. Mass is the quantity of matter an object has. It's not weight because weight is the force produced by gravity. So your weight would be different on the moon than it would on Earth. The mass, however, would be the same. So anything that has mass is matter. An element is a substance that cannot be chemically broken down. If you look here, this is one element from the periodic table of elements. This is carbon, so it's got the big C. Some of them, the names make total sense. Carbon, C. Hydrogen is H. Some of them that don't make as much sense, like sodium is Na, it's because the names are actually from Latin. So sodium in Latin is natrium, so natrium Na. Each element, if you look on the symbol box or on the periodic table, the number above it is called the atomic number. So that right here. So carbon's atomic number is 6. That is the number of protons and electrons. Underneath is the atomic mass. So 12.011, or usually it just goes by 12. That is the number of protons and neutrons. And then, like I said, each element, they're all on the periodic table of elements. Looks like this. If you click on the link, there will bring you to an interactive periodic table where it'll tell you more about each element. The ones we're mostly going to focus on are hydrogen, carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur. A couple of these, silver and gold, but there's a whole bunch that are man-made down here. They don't really apply to biology. But so each atom looks something like this. In your atom reading that you guys did, this is what they were trying to design or figure out, is the structure of an atom. What do they actually look like? So an atom is the simplest particle of an element that retains all of the properties of the element. In the middle, this region here, there's the nucleus. So just like in the middle of a cell, there's a nucleus. In the middle of an atom, there's the nucleus. The protons and the neutrons are in the nucleus, and the electrons are in the electron cloud around that. So, like I just said, the nucleus, it's in the middle. It's the central region that makes up most of the mass of an atom. And it has two subatomic particles, the proton and the neutron. The protons are positively charged. Positive proton. The neutrons have no charge. So think neutral, neutron. So no charge. The number of protons in an atom is the atomic number. And the mass number is the total number of protons and neutrons of the atom. Electrons are what are around the outer rim of the atom. The electrons are negatively charged particles that move around the neutrons. So electrons are negative. Atoms are neutral because there's an equal number of protons as there is electrons. So they cancel each other out. You have 6 protons and you have 6 neutrons. So Positive 6, negative 6 gives you 0. And the electrons are in the orbital around the nucleus. So all of these here, these are all electrons. They are outside of the atom. They are not in the nucleus. This is just a little chart summing up what we just went over. So the neutron, no charge in the nucleus. 0 for the charge. Proton, P, positive. They're in the nucleus, charge of +1. Electron, E to the minus. So this is the symbol for electron. You'll see like you could write like 2 electrons. The E with the minus, that means electron. That's like shorthand for electron. They're in the electron cloud. The charge is -1. And if you look here, the mass, it's an AMU, that's like atomic mass unit. It's a really, really small number. The neutrons and the protons are the same. The electrons, really, really tiny, even in comparison to the neutrons and the protons, which are small. If you look at all these zeros, how much smaller the electrons weigh, how much less mass they have than the neutrons and the protons. And then if you are trying to figure out how many protons something has, you just look at the atomic number. If you're trying to figure out how many electrons something has, you can look at the atomic number, because the number of protons and electrons is the same. If you want to know the neutrons, it's the atomic mass minus the atomic number. So these are 3 things that you will definitely need to know how to figure out. Again, the atomic structure, the electrons outside. So hydrogen has 1 proton in the nucleus, no neutrons, and 1 electron. Nitrogen has 2 in the first orbital. I'll talk about those in a second, but I'll talk about them now. The orbitals, this first level, you'll notice there's 2 here. Oxygen right here, there's only 2. The first orbital can only hold 2 electrons. The second one can hold 8, and the third one also holds 8. So nitrogen has 2 in the first one, and then 1, 2, 3, 4, 5 in the outer one. That makes up the 7. 7 electrons, 7 protons, 7 neutrons. Helium, 2 protons, 2 neutrons in the nucleus, 2 electrons on the outside. And like we said, the number of electrons matches the number of protons, so these are neutral. The elements that we're going to be mostly concerned about are the SNOPs, or SNOPs, however you say that, and that's carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. They are the 6 biologically important atoms, and they make up 99% of living tissue. There's 92 other elements that occur in nature, and the other ones are man-made. And then from each element, there can be an isotope. An isotope is an atom that's the same element. So if it's carbon, it's still carbon. The only thing that's different is the number of neutrons. So down here we have carbon, actually. Regular, and when I say regular, I mean the most commonly found carbon is carbon-12. That means it has 6 protons, 6 electrons, 6 neutrons. An isotope of carbon, carbon-13, has 6 electrons, 6 protons, and 7 neutrons. And an even less rare isotope of carbon, 6 protons, 6 electrons, 8 neutrons. So these all 3, carbon-12, carbon-13, and carbon-14, they all have 6 electrons and 6 protons. But the number of neutrons is different. That's what makes it an isotope. Okay, that's all the notes you need to take for the first section. So if you need to go back, if you didn't already, please do make sure you have things like underline, words that are in your vocab, and that's it. Hopefully this went well and you enjoyed it.